Hello everyone, welcome back to Pre-Algebra with Ms. Betsy. We are on section 2.4 today and we're going to be talking about the distributive property. I'm using as my text Pre-Algebra for Christian Schools by Bob Jones University Press. You can use any other text. You're going to be covering these same topics in any pre-algebra class. Before we get started, I have my lame joke of the day from my Sticker Mania dot to dot book. I want to show you this picture. If I'd taken the time a long time ago, I would have probably enjoyed coloring this one. What do sea monsters eat for lunch? Well, they eat fish and chips. Where I grew up in Pennsylvania, we had Arthur Treacher's fish and chips a long time ago, and chips were of course the English way to make French fries. British way. So right there is the sea monster who is enjoying fish and chips for lunch. So we're on page 50 in the Bob Jones book, talking about what they call the distributive property, and it has a long name. It's called the distributive property of multiplication over addition. Let me just go ahead and illustrate it to you just by using some numbers. Say if we had 4 times 10 plus 25, the quantity 10 plus 25. Using order of operations, you would add with inside the parentheses, and I'm going to just bring this over here. We would have 4 times 35, and then you would say 4 times 35, 4 times 3 is 120, 140. However you would go through it, you would end up with 140 as your answer. And sometimes it's convenient, sometimes it's not to go ahead and do that arithmetic in your head. You don't have to do your arithmetic in your head. The more comfortable you get doing mental arithmetic, the better it trains your brain, the more rapidly you can do things at times. The more that you can look at an answer that you punched into your calculator and said, that is just not right, let me recheck that. But for those kids who are in my pre-algebra class, you're still not allowed to use calculator. But now let's look at this over here and think about an illustration of the distributive property. I've told you that I like to use numbers that relate to money. Well, we've got a dime and we've got a quarter here. Obviously not, because it's not 0.10 and 0.25. But I'm going to pretend that I have 4 10-cent pieces, that I have a 10-cent piece and a 25-cent piece. But I have 4 of them added together. Well, wouldn't that be the same as saying 4 dimes plus 4 quarters? It would. 40 cents plus $1 gives me $1.40, or in this case, since we have pure numbers, it's just 140. Was this method here quicker and easier than doing this? Probably not, but once again, we're just illustrating a property, illustrating a principle here, and this is what they call the distributive property of multiplication over addition. It's because what you have is you have a factor that you are multiplying against a sum of numbers, and it doesn't have to be limited. We could have had 10 plus 50 plus 100, because we have dollar coins now. We didn't have dollar coins when I was growing up. We did. We had silver dollars and everybody saved them. We have different dollar coins now. If we had 4 times 10 plus 25 plus 50 plus 100, we did our computation of this amount based on following order of operations. We would add with inside the parentheses first, and we would have 4 times $1.50, $1.75, $1.85. 4 times 185, and I'm going to go ahead down here and multiply this by 4. 4 5s are 20. 32 and 2 is 34. 3. If I didn't make a mistake there, I have 740 is what the value of this expression is here. Now, let's go ahead and use our distributive property and see what we end up with. Well, we have 4 dimes, and we have 4 quarters, and we have 4 50-cent pieces, and we have 4 dollar coins. 40 plus $1 plus $2 plus $4. 4, 5, 6, $7.40. So you have 740. So just a further illustration of this distributive property, doesn't matter how many addends, how many items you have within inside the parentheses. You're just multiplying this outside factor against each one of those. This is what they call, once again, the distributive property of multiplication over addition. Am I going to expect you to say distributive property of multiplication over addition? No, but you have to be able to know that it's the distributive property. And what this says in the language of algebra is for all whole numbers, A, B, and C. I don't want to use an addition sign. And C. In other words, what they're doing is they're giving us a general rule here that we can follow. A times the quantity B plus C is equal to A times B plus A times C. Now notice how I read this. A times the quantity B plus C is equal to A times B plus A times C. A times B plus A times C. This is essential that you are able to work with the distributive property. Now, I want to go through and take the time to step through all 3 examples in our book, and maybe yet another one, because we're still working a lot with just the vocabulary of algebra and learning how to do, I guess, the English translate from English to algebra and understand exactly what they're asking us to do, and understand that this long string of English words means, oh, doesn't matter which number I put first when I multiply, doesn't matter which number that I put first when I add, it doesn't matter when I'm multiplying if I group inside the parentheses first or not. So what we have, this says write an equivalent expression for this, 4 times the quantity m plus n. Once again, use an equivalent expression. Does it look identical? No, but it means the same thing. What's our distributive property say? It says when you're multiplying a sum, you can break it apart individually, just like you're grouping together your coins. So this is 4 times m plus 4 times n. Now what I've written here, I really don't want you to write, but some of you are still going to say 4 times m plus 4 times n. It's really 4m plus 4n, because this expression here, the 4m, means 4 times m. The 4n means 4 times, this means 4 times m, this means 4 times n. So you don't even need to write that step. And what you've done here, going from this expression 4 times the quantity m plus n to 4m plus 4n, is very, very valuable when you get to where you're solving problems. So that's example number 1. Let's see what example number 2 looks like. We have write an equivalent expression for 7 times 3 plus 7 times 9. We don't have any parentheses here, but we know that when we have multiplication and addition in the same problem, that using our order of operations, we're going to multiply first. But the question says, write an equivalent expression using the distributive property, and this is where you have to be able to go backwards in it. We've got the same thing multiplied together. 7 times the quantity 3 plus 9 is what they want you to do. I think at this point it would have been very easy, just from watching this little lecture, even if you didn't already know, to say, oh, this is the distributive property. So that means I can go 7 times 3 plus 7 times 9. But it may be a little bit more challenging to realize that you can go in the opposite direction. Remember what I've said about equal signs? It's like a balance beam or like a seesaw. Same. Doesn't matter if you're looking at it from the front or from the back. They're both balanced. So what you have on this expression, this side of the expression, is identical. So this principle right here, where you can go backwards, if you will, using the distributive property, that is very, very, very important. I don't want to do this last example here. To me, it's a little bit contrived and not something that I would use. But it's still an illustration of what you can do. You have a plus 3, the quantity, times 5. And they want you to use the distributive property here. So what they say is, we're going to go this way. A times 5 plus 3 times 5. A times 5 plus 3 times 5. Just look at that, see what they've done. Because we could say 5 times A plus 5 times 3. If we use the commutative property to switch these two factors around. Not a whole lot I can say on this one except look at it, puzzle over it if you need to, and realize that applying the distributive property using this method is equally legitimate if you get to a problem where it's helpful to you. Now let's look in our text at problem number 6. As soon as I finished erasing, 2 plus 13 times 17 is equal to 2 times 17 plus C times 17. And what they're doing is they're asking you find the value of the variable. And I jumped right into a hard one, a harder one, not difficult, as long as you understand how the distributive property works. And this actually is taken directly from the example 3 that we just did. You have 2 times 17 plus 13 times 17. 2 times 17 plus C times 17. What does C have to be equal to? C is equal to 13. There's no computation involved here. There's just an understanding of what the pattern looks like when you apply the distributive property. Let's look at skill check number 5. And this says write an equivalent expression using the distributive property. This one right here, totally simple now. 2 times the quantity, 5 plus 8. Well, that's the same as 2 times 5 plus 2 times 8. Very, very straightforward. You're going to say, goodness, this just gets monotonous. It does. Now, number 15, we're talking about mental computation. And this is where you're breaking numbers apart. 5 times 14. A lot of you can very easily do this multiplication and you have 5 times 14 is 70. But you can also break apart in your head the fact that you're saying 5 times 10 plus 5 times 4. What this is they're using place value. You have 5 tens, you have 4 units. 50 plus 20, you end up with 70. But what they're saying is use the distributive property to compute mentally. So you're not doing this. You're saying, oh, I have 5 tens is 50. I have 5 fours is 20. 50 and 20 is 70. So let's do another one of those. We have 3 times 40 plus 3 times 60. How can we apply the distributive property here so that we're doing this multiplication mentally? Well, we're sort of saying, oh, 40 plus 60 is 100. 3 times 100 is 300. So those are some examples from section 2.4 on using the distributive property. Play around with them some. Give yourself some leeway and some latitude as you're learning the definitions and the applications of these principles, and have a little bit of fun with it. I'll see you next time.